In this video, we will talk about permutations. So, look at the definition. If there are n total objects in a set A, and there are r different positions where r is less than or equal to n, then permutation is the total number of ways to arrange r objects on r different positions. It means that first you have to choose r elements from n, and then you have to arrange them on r different positions. This is the definition of permutations. So look how we can uh, drive its formula, right? So let's look, we have a set A. Let's have a set A containing n objects. Right? So we have to suppose that there are different positions r is less than or equal to n. Okay, we have r different positions and we want to arrange r elements out of n total objects, right? Look at the diagram below. You have the first position, right? And then you have second position, and then you have third position, on and on and on. Then you have r minus 1th position, and then you have rth position, right? Then you have rth position. Okay, so now you want to fill these positions from these n elements. So look at the set. We have a set containing n objects. A has objects n. So you will fill first position from n different objects. So how many ways are there to fill first position? N different ways are there. So I can write number of ways to fill first positions are n, right? So once we have filled this first position, then one element is consumed out of n elements. How many elements are remaining? Definitely n minus 1. Remaining elements are n minus 1. So from these elements, you have to fill second position. So how many choices do you have? N minus 1, of course. So number of ways to fill second position are n minus 1, because we have only n minus 1 elements which are left. Okay, once you have filled this second position as well, so how many elements are remaining? N minus 2, because we have consumed one more element. First element here, second element here, and we have left n minus 2 elements. So how many choices are there to fill third position? N minus 2, right? So number of ways to fill third position are n minus 2. If we carry on this step, number of ways to fill r minus 1th position, number of ways to fill r minus 1th position. Look at this. For the first position, number of ways are n. For the second position, number of ways are n minus 1. For the third, number of ways are n minus 2. You can see, if here is 3, then what is 1 less than 3? That is 2. We have subtracted 2 from n. Here you have n, you have 2. And what is 1 less than 2? That is 1. We have subtracted 1 from n. Here we have first, what is 1 less than 1? That is 0. We have subtracted 0 element from n. So we will do the same thing. Here we have r minus 1. So what is 1 less than r minus 1? That is r minus 2. So we have to subtract r minus 2, which is n minus r plus 2. Got it? Okay, now how to fill nth rth position? What is 1 less than r? That is r minus 1. So we have to subtract r minus 1 from n, which is n minus r plus 1. So we have filled all these positions. We have filled this as well, we have filled this as well, we have filled all these positions as well. Okay, so how many total number of ways are there? Total number of arrangements are, it is the product of all of these. Okay, you can write it here. It is equal to n times n minus 1 times n minus 2, because here you have n, then n minus 1, then n minus 2, then on and on and on, n minus this thing, n minus r plus 2, okay, on and on and on, n minus r plus 2, and then n minus r plus 1. We have to complete the factorial. You can see n and then 1 less than n, then again 1 less than n minus 1. You can see this is 1 less than this is 1 less than this, and every next term is 1 less than previous. This term is 1 less than previous. So we can construct a factorial. How can we construct factorial? N minus 1, n minus 2, on and on and on, n minus r plus 2, n minus r plus 1, and again we have to complete the square. What is r, sorry, n minus, sorry, we have to complete the factorial, n minus r, on and on and on, 3, 2, 1. Since these terms were not in the original expression here, we have written down these terms by ourselves, so we have to divide them as well. N minus r, on and on and on, 3, 2, 1. So what is this term? This term is n factorial. You can see n minus 1, n minus 2, up to 3 to 1. So this is n factorial. And what is this? This is n minus r factorial. So this is the formula for arranging r objects from n objects. It is denoted by npr. It means there are total n objects and we had arranged r of them, and the formula is n factorial over n minus r factorial. We will use this formula to solve some examples. So look at very first example. We have a set E of alphabets. We know that alphabets are total 26 in total. So find the number of 5-letter words that can be formed from set E such that the first and last letters are distinct vowels and remaining are consonants. So what we have to do? We have to make 5-letter words. Here you can see 5-letter words, and such that first and last element is vowel and other 3 positions are filled by consonants, right? So we have to do that. Okay, how will we solve it? Look at vowels. How many vowels are there? Total vowels are 5. Total vowels. And how many vacant positions are there for vowels? 1 and 2. These are 2 total positions. So this is n and r is 2 vacant positions. So how many choices are there? Okay, that is npr. N is 5 and r is 2. So I have done the same thing here. Total number of vowels are 5. Total number of positions for vowels are 2, because this is 1 and this is 2. We have 2 positions for vowels. So it is n and this is r. Okay, this is n and this is r. So to fill n positions, we have total 2p 5p2 number of ways, right? So what is 5p2? 5p2 is 5 factorial over 5 minus 2 factorial. Here you can see. Okay, 5 factorial is 5 factorial over 3 factorial. 5 minus 2 is 3 factorial. Then expand this thing, you will get 5 times 4, which is 20. Got it? So 5 P2 is 20. Now, what's the next? We have filled first and last positions. Now, these 3 positions are left. So for these 3 positions, we have to use only consonants. Total English alphabets are 26. 5 of them are vowels. And how many of them are remaining? They are 21. They are consonants. They are vowels. So 5 of them are vowels, 21 of them are consonants. So for these 3 positions, we have total number of words 21 and total number of positions are 3. Right? Since remaining positions are to be filled by consonants, so these are 26 minus 5, which is 21 in number. So how to fill these positions? NPR, which is 21P3, you can see here. So what is 21P3? That is 21 factorial over 21 minus 3 factorial. You can write it in this way, 21 factorial over 18 factorial. You can expand 21 factorial up to 18 factorial in this way to cancel out 18 factorial on the numerator with denominator. And after multiplying this, you can get 7980. So the total number of ways are the product of these two, because both are half events. So their product is 159600. So these are total number of ways to fill 5 positions as required.